Alright, we've got an A1286. Bit of an older machine from 2012. This is a 15-inch MacBook Pro unibody. And the claimed issue is it will run off the battery, but it will not charge the battery. So I don't see any evidence of liquid damage. So we'll go ahead and open it up and take a look. I had to wipe the screen off because the screen was a little dirty. And I'm going to option boot from an external so I don't reveal the owner's information. So grab my external boot drive here. Plus I want to check how much battery there is. We're going to hold option and press the power button. And we did get a chime. Sorry, I'm going to do this just to make sure that people's information doesn't pop up. Alright, and so we've got our list of available operating systems, Mac OSs. We're going to just do High Sierra. So as you can see, it does work, but the customer said that it will not charge the battery. Now, it could have suffered liquid damage, and they might have ultrasonic the board and didn't tell me, which would not be surprising. So we got 63%, so, you know, it does see the battery. We'll plug our charge cable in. We're going to use an authentic MagSafe 1. We're going to plug it in to the side. No. Yep, and we are not getting anything. We're not getting a green light or anything, and there's no indicator popping up a lightning bolt. There's no lightning bolt inside the battery icon, so it is not charging. You can also confirm that with coconut battery. It's discharging with 29 watts. So we are definitely not charging. This is I don't think this computer's been ran very much. It's got the original battery in it. 7/11/2012 was the manufacture date, and it still has, according to Coconut Battery, take that for what it is. 95% design capacity, 201 cycles, practically brand new. So I don't know how long this has been broken, but yep. So as you can tell, the computer works. It just will not. It's not recognizing the charger. So doesn't seem to me, if it can see the battery, that means our SMC data lines can see the battery, but we can't charge the battery. So that would lead me, I'm going to go ahead and shut this down. Well, unplug the MagSafe. Unplug the MagSafe so you can see that it's still running off the battery. That would make me lean towards a charging circuit problem, like I'll have to look at this the board view and schematic here. I'm going to close that. It's looking like U7000, which is our ISL 6259. Yeah. And then I can confirm that with my power supply. This is actually an authentic MagSafe 1 cord that I cut up and put banana jacks on so I could plug it into my power supply so I could see how much current the computer draws. I mean, the battery is still hooked up, yeah, but it's drawing 6 milliamps. So, yeah, so it's safe to say our charging circuit is not working, so we're going to shut this down. Take the board out, or take a look at the board rather, and see what we can find. I'm going to take the bottom off here. Shall leave that hard drive out. I'm going to take the bottom off without closing it because there's information on the bottom that I don't want to reveal. Sorry, I've got someone's texting me. Yep, I gotta take the bottom off. Sorry, excuse me for a second. All right, back to it. So I'm gonna go ahead and get the screw box here and undo the bottom. I'm gonna do it with it open because, like I said, there's information on the bottom here and I don't want to reveal it. You know what I could do? I'll just put it on my lap for a second. Let's do it this way. So just undoing the screws right now out of the bottom of the computer. So many screws, so many screws. This video's been going for 8 minutes already. I'll try to make this a quick one if I can. I know all my videos have been like an hour and a half to 2.5 hours long. I'd like to make one that's like an hour or less, 45 minutes. All right. All right. Take the bottom off. And we're back. Okay, we're going to undo the battery. And we're going to take a look at the charging circuit first and see what we can find. Now, okay, let me see if I can show you. Let's go to scope cam. And of course, I've got to deactivate and reactivate my camera. And as you can see, we've got some damage here. Some liquid damage. So I do in fact think that this logic board was ultrasonicked because the corrosion is all gone. I mean, you got some remnants of stuff here, a little bit, but yeah, I believe this board has been cleaned. I'm seeing a couple of components that don't look good. ISL looks okay. That's our charging. This creates PP bus. And then this dual diode right here. Is it dual diode? Yeah. Or is it a... This is... Yeah. 2 diodes. This is D7005. So this takes battery... Does it get... Oh... No, it's charger ACN. Charger ACN and from adapter. So it looks like this PPDC and S5 charger comes from our adapter. So let me see if I can show you my flex board view. So we're right here. This is U7000. Here's D7005, which is this dual diode here. And let's go back to flex board view. So this is D7005. This is PPDC and G3 hot, which comes through F6905. So it turns. So basically, if you click on this one, here's our DC in. This is our adapter, like our DC in board. And so, you know, 20 volts comes from here and goes into this fuse as 18 V5 or PP 18 V5 DC and fuse turns into PPDC and G3 hot. Charger A gate and divider. So it goes from there to a couple other places. Yeah, this is like inrush. But then it comes here. To pin 1 and 2. Which you look on the PDF, which I can't show you. Pin 1 and 2, yeah, are here, and it comes in, goes through D7005 into R7005 through R7005, and it goes in here to power our U7000. Because if you looked at the schematic, which let me do my monitor. I just want to make sure I don't have anything open that I shouldn't. So if we go to monitor, see D7005 is here from adapter. Goes through R7005, which is a 20 ohm resistor. Becomes charger DCN. And then DCN. So DCN goes into U7000. U7000 creates PP bus. G3 hot. So, we need to check this resistor and this resistor because they don't look too good. These other things are just a little grayed out. I'm not, it's just, yeah, it's just a little dirty. Not too concerned about that. That capacitor looks a little gray too, just like it's just covered in film. It's not actually corroded, so I don't think I'm going to mess with that one. I am going to check the connections with all these copper lines, or copper test points. I'm going to make sure those are actually connected. But what concerns me is this resistor and this resistor. You can see that the metal end caps are actually falling off of this one, almost completely gone on that one. And that resistor is, the top one is R7005. The bottom is R7010, and that's PBDCN. Comes from the same spot. Goes in as charger ACN. So it's kind of, that's an important, those are important resistors. So I think we're gonna attack that first. Now, another thing that concerns me is that there's no green light on the charger. But I think we need to attack this first. Yeah. I think we might have two problems. So we might have a problem with our one-wire circuit. And we have a problem with our charging circuit. So we're going to address the charging circuit first. I mean, the computer does run. So we can check the SMC. Is the SMC on this side of the board? I have no idea. I've honestly never messed with the SMC on this computer. I have a feeling it's on the other side. What do they call the SMC on here? U4900. Yeah, so it's on the other side of the board. So we may have to check our one-wire circuit too. Our adapter sense line, U6900. It's this one wire. So that's actually on this side of the board. Up here next to U5701. Is that right? Yeah. Actually, it's over here. Yep. So we'll have to take this shield off here and see if there's any corrosion under there. SMC BCAC okay. So there's a couple of, yeah, those guys look okay. So we'll have to check around and see why we don't have a green light, but we're going to address the no charging first. So I think what I'm going to do is pull the board out. I could solder, fix all those resistors with the board inside the computer, but that's just not my style. Don't want to say it's lazy, but it's definitely, you know, a quick way to do things. And since I'm not really in a rush, I think we'll go ahead and remove the logic board out of the case. We need a T6. T6. We'll just start undoing everything. I guess I could measure those resistors, but I'll do that when I get the board out. We already know they're no good, but we're going to find out just how no good they are. And I'm pretty sure that they are affecting the no charging. Now the no green light, that is a separate issue, I imagine. I could be wrong, as there's only been a certain amount, only a few of these I've worked on, this particular logic board. This is an 8203330. Haven't worked on a lot of these. So, but usually if we don't have a green light on the charger, there's something wrong with our sys one-wire circuit, which goes to our SMC. Now, could that be caused by the corrosion next to the charging chip? I don't know, to be honest. But we're going to find out in short order. Oh, I still got to take this little bracket out of the corner here. Do we have to take that bracket out? I don't know if we have to take that out, but I guess it will. Might just make life easier. Alright, what are we hooked on? On you? Okay, we're not hooked. Alright, there we go. We are out. We'll take a look at our SMC as well. Let's take a look at the SMC really quick. Why does my seat seem like it's shorter? Back to the scope cam. Oh. Where are you, Mr. SMC? Oh, you're on the other side of the board, that's right. I think that's you right there. Yep. Once again, I forgot that I flipped the board over. So that's our SMC. There's like cotton fibers here. I don't know, somebody's... Imagine this board is ultrasonic. I don't know if someone's been here or not, but this definitely looks like it's been cleaned a little bit or something. Possibly. Don't know that I see a little bit of what looks like a little bit of liquid here. I'm not sure. I guess I can gently pull the microscope to the edge of the desk and hope to God it doesn't disconnect and turn my computer off and ruin this video. I'm looking under the SMC and I don't see anything that raises alarm bells. But who knows? Can I see this under the side? Nope. Not the optimum place for that chip to be sitting. I think I just saw U6990. I recognize it from MacBook Air boards. We'll try to fix that charging circuit first, and if we still don't get a green light, then we can look at addressing our one wire circuit. Let's see why we don't have a green light. Okay. There's our resistors and stuff right there. Alright, so the top resistor, and by top I mean this one, that guy is, what did I say? R7005. Now if we go look on the PDF, it should be 20 ohms. 20 ohms. What do we get? Let's see. Put our multimeter on ohms mode. And we're getting 480 kilo ohms. That's not good. That should be 20 ohms. Which means that resistor has failed, has burnt, has shorted inside more than it usually is because it's a coil wire. Burnt up, probably got some carbon in there now. It has now went from 20 ohms to half a mega ohm, which is not good. Which will significantly drop the voltage from this, from D7005, as it comes out pin 3 to this resistor, will be 20 volts or thereabouts. But then on this side of the resistor, it's going to drop down quite a bit, and therefore it's going to come through here and drop down, or it's going to be, yeah, it's where it goes into this pin here on our ISL, and it's not going to be very high at all. And in fact, we'll measure it. We'll go ahead and plug some power into it and switch our, I'm going to switch to overhead camera and bring my multimeter in so you can see the voltage. We'll bring the screw box here. Alright, I'm going to plug in a MagSafe connector into the board. And we're going to measure what the voltage is on pin 3 of D7005. Okay. Yeah, that's not good. So maybe that's from the battery, when I had the battery plugged in. It's at 345 millivolts right there. That's not good. It's 0 or 322. And you can't even measure it on this resistor. Basically, you get the idea. How come that's not showing up? Oh, it's probably because, yeah, that diode's on adapter, or is on AC in, so there we go. 20 volts. So we have 20 volts here on pin 2. Pin 3, 1979. Okay, a little voltage drop there. On one side of the resistor we got 1979, and on the other side oh, we have 1899. Okay. So that's not that bad. Why aren't you turning on then? What about here? Yeah, we're getting nothing. So that is, so that line So this top resistor is PP charger DC in. So yeah, the charger would make sense if it's seeing the charger, which is weird because that, oh, it's 4.8 volts now, yeah. So I'm not sure what happened there. So now I'm measuring 19 on that side and 5 on this side. So yeah, there's a problem. So our diode's okay. Let's go to resistance and measure the other resistor. Measure the second one down. I don't imagine it's going to measure anything. Measure this guy. R7010. PBDC and G3 hot, which comes from pin 1 and 2 of D7005, excuse me. Tired. Goes to charger AC in. And your value should be 30K. I doubt it. But let's measure. What does it say? $275K. That's way above 30K. So that's not good. Let's put this in continuity mode. We're gonna check these traces on these other resistors and make sure they're still connected. So yeah. Let's see, how do I get my probe in here? Trying to touch this pin. Okay. Let's come from this angle. How about this? So that's good. Good. So those traces are still good. They're just, yeah, it's just the shiny stuff's gone. So, do I have a donor for this board? I don't even know. We're going to rip those 2 resistors off and replace them. And see if we can't get the charging circuit to work again. 3332. That is not the same board. I imagine the charging circuit on all of these are the same because they all use an ISL 6259. So I'm willing to bet. We're going to move this board and look at our donor board and see, look for our ISL and see if we can find similar. Nope, that's TPS. There's our ISL. So that ISL, is our ISL upside down or right side up? It's right side up. So that's, so that top right or top left corner is pin 1. So there's like a resistor and a capacitor next to the diode. And then on this board, yep, I think this is the same resistor. And then the other resistor is next to D7005, wherever he is. So we'd have to look this board up. This is a 3332. So we'll look up a 3332 board and see. And what I'm looking for is donor board. So that is in fact R7005 on this board, and it's 20 ohms, which is the same as our other board. That's R7005 on that board. Yep. So now we need to find an R7010 on this other board as well. R7010. What do you know? It's actually right there. And what value is that? 130K. Which sounds about right on our other board here. Nope. It's not. Ours is 30K, not 130K. Our D7005 resistor is the same. We need to find an 30.1K 0402 resistor. So we're going to do Control F. 30.1K. That's a 201 size. And that looks like the only 30K resistor on this board. Alright, well. Let's see. What if we just do 30K? No, that's 330K. 330K, 330K, 130, 330. 30K, 201 though. Alright. We're going to have to get a little more adventurous. We're going to go ahead and pull those resistors off of our board. And I'm going to get my multimeter out of the way. And we'll just have to find another different donor board that's got the same charging circuit layout. It's got a 30K, 30.1K resistor. Because 820-3330, which is from a Retina, 15-inch Retina, will not cut the mustard. So we're going to go ahead and fire up the hot air station real quick and get rid of those. Just kind of warm up the board from far away for a second. Try not to melt the RAM slots. Gone. And gone. And now we're going to get our stand in. Or actually, no. You know what we're going to do? We're going to put some flux here and maybe a tiny bit more solder so those resistors will stay on. Oops. Tight space. Alright. Good enough for now. We're going to pull out our donor board here again. And confirm. These boards are huge. And confirm which resistor we need to steal. We need to steal R7005. Which is the top one next to our U7000 on this board. Okay. Get the flex board view out of the way so I can see what I'm doing. Alright, we got that guy put in, and now we need to find another board that's got a 30k resistor, 0402. I just realized I don't have my fume extractor on, but I'm not creating. This is going to be a pretty quick solder job, so I'm not too concerned. Alright, let's see if we can find a 30k. Finding a lot of 330Ks. Am I going to have to go to my resistor book? Where's our U7100? This is our ISL on this board. Nope. 165s are out. What about 3115s maybe? Bingo. R7010. Ha. On a 3115 board. Alrighty. We're in business because I have a whole bunch of those. I've got 5 or 6 of those logic boards. Yay. Alright, we're going to switch boards here real quick. There's our old pal ISL. Now we're going to steal the resistor off U so that this A203330 can live again. So we'll go third one over from C7005. So 1, 2, 3. So it's you. You're coming with me. Put a little more flux on there. So it don't go taking off on me. Oh, I got him facing the wrong way here. Got to turn you and orient you correctly. Just like that. Touch them up again real quick. Make them nice shiny solder pads. Or solder ends. Solder blobs. Alright. Do a little cleanup here. I'm not going to go crazy and ultrasonic this entire board just because I replaced 2 resistors. I think that would be a little bit silly. Now the eye itself still could be dead. Let's hope not, but I guess anything's possible, huh? Anything's possible when you're fixing a MacBook. Now, I may nitpick a little and replace that capacitor too. Although he's still on the board, I don't particularly love the way he looks. I'm assigning a capacitor a gender. That's hilarious. That's hilarious. Come on, dry. Dry out already. Alright. Now, I wonder what kind of action we're going to get. I'm not going to get my hopes up, but see. Can measure those resistors again. Can I see them without my microscope? Probably. Oh, not continuity. $20 ohms. 30K. Cool. So our charging circuit should be working now. And look at that. Hello. What is that? That looks like a green light and a fan spin to me. See that? Nope, you don't see that because of the light. That's a green light, and those are spinning fans. Huh. Look at that. Didn't measure PP bus, didn't measure PP3V42, didn't measure anything. All I did, it's got sticky stuff on it. Interesting. All I did was go straight to the charging circuit. So, Yeah, alright, we're going to go ahead. Where are we at in time? 50 minutes? Great. We're going to go ahead. We're going to go ahead and pop this in the case real quick and see. See what we got. I could be a stinker and just end the video right here. And just say see ya. Alright, fan spin, we're done. But no, we want to see this charge. We want to see it charge the battery, don't we? Of course we do. All because two little resistors that cost pennies were corroded. Not gonna judge. I don't know what happened. There was a party or something and somebody spilled something on the MacBook, and then my customer or the owner did that, and then my customer decided they would ultrasonic the board before giving it to me, which is never a good idea, because you basically take away any of my clues that I would otherwise have. We're just gonna temporary plug stuff in here. So I imagine my OCD is gonna get the best of me, and I'm gonna wind up replacing that capacitor too before we send this board back to the customer. Now I always like to throw like one logic board screw in just to hold the board in. Never had anything traumatic happen if I've not done that. It's just I like doing it. I have, and I'm not proud of this, I have worked on a MacBook Air a long time ago, and I didn't realize the battery was not fastened down, and I turned the computer up like this and the battery fell out and ripped the battery connector out with it. Or ripped the battery connector right off the board. So that was my first ever battery connector replacement, which at the time was not fun because I didn't quite have the research and the technique down to do that job quickly and easily. I've since then developed a great method for that. Did I put the fan screws in with everything else? You dummy. Oh, you big dummy. Are they all the same size? That one is not. That's a fat screw. We're going to put you here, if you want to go there. If you don't, just say so. You big dummy. Why? Why did you do that? Why, oh why did you put... I think that's the other fan screw. That's a short, or a real skinny head. We're going to put you there. Alright, I think that's probably good. Yeah, alright. Good enough for now. Plug the LCD in. Sorry if I'm talking low. It's 3:30 in the morning. I'm tired. It's late. I wanted to get as many computers fixed as I can so I can enjoy my Saturday. Alright. I think it's safe to... We gotta plug the battery in because that's the whole problem, was the battery wasn't charging. plug that in that way, and we're going to option boot because I once again, don't want to reveal any information about who my customers are. We'll go ahead and power it on. We got a green light on the charger. And we are option booting. Nice. 55 minutes. Alright. Cool. Alright, so let's boot into High Sierra. And my power supply is definitely going nuts. So I guarantee you the charging circuit is working because it's drawing 3 amps. Which my power supply can barely provide. That power supply anyway. I have another power supply that can provide up to 6 amps. But we're at 2.7 amps, so yeah, I would say the charging circuit is working. And we have, orange light. Oh, beautiful. Look at that. Look at that. Super secret password. We'll switch to scope cam. Oof, let's raise that if we can. Try not to kill the video. Let's focus. I'm gonna move the computer a little bit. And what's that you see right there? What is that? Beautiful. Blurry. Look at that. That, my friends, is a battery symbol with a lightning bolt in it. Which means our battery is charging. I'm going to go ahead and unplug it. Oh, look at that. And we're going to plug in our other MagSafe, our original 85 watt MagSafe, to see if I said we're going to plug it in. Isn't that working? There we go. Beautiful. Look at that. Oh, that's awesome. Fixed. 2 resistors. R7005 and R7000 or 7010. Was the reason why this poor old machine, 9-year-old machine, couldn't charge. These 2 little resistors on PP charger DCN and charger ACN were broken. That's beautiful, beautiful, beautiful. Let's watch it for just another minute. Go up to 63%. Charge, little MacBook. It's crazy, you can see all the pixels in the screen. That's what happens when you're zoomed in. I mean, we'll go to coconut battery. Yep, it says charging with 42 watts. So we are charging. Charging the battery now. I don't think I can raise. Can I raise this? So you can see. Probably not going to be able to raise it because I got. Yeah, no. Here, I'll move it back and turn the scope cam back on. I don't want to unplug anything. Look at that. Fixed. Alright, that's it for this video. We're at right at an hour. So that's perfect. Anyway, I'm going to clean the fans out on this thing a little bit. Seems to be running pretty cool, actually. Yeah, it's running pretty cool. I'm going to blow the fans out clean, and I might replace that capacitor. Otherwise, this one's ready to go back to the owner. So, yeah. Thanks for watching. Take care. Bye.